interesting on that second poll question there. I would also put myself in that second category of some experience. I am by no means the Azure Function total expert, but I have been doing some proof of concept applications in there, and I think this is going to be the right audience. We're going to show you how to build an application with Azure Functions and the things to think about and how we scale that application. Let me move on to a little bit about me. So I am a senior BI consultant at Pragmatic Works. There's my Twitter information up there. This is kind of standard boilerplate stuff, but as far as me being a data geek, I love all things data, whether it's business intelligence, data warehousing, data analytics, Power BI, all that kind of stuff excites me. I love playing around with data, and this application that I'm going to show you is a good example of that. Basically, just to kind of teach myself Azure Functions, I built a data app, so something that can generate hundreds of thousands of text files. So I like to just play around with data. I'm a tech enthusiast. I like to say I'm a gadget geek too. I've had everything from Google Glass to I've played around with HoloLens. Right now I'm doing virtual reality and augmented reality programming. Don't be surprised in a future session if you see me doing a VR app with SQL. So I have this grand vision of being able to envision your SQL database as a city and the tables as buildings and so on. So I love to mess around with technology. All right, so let's get to the core of what this webinar is about. How do we build a scalable application with Azure Functions? Well, first we have to answer a few fundamental questions. First is what do we mean by scalable? What does that mean in the terms of an application built in Azure? The second thing is going to be Azure Functions. What are the basics of how they work? How do they scale? How do we deploy them? How do we build them? And how do we design architecture that will utilize Azure Functions? And then lastly, we'll actually walk through the application that I built. I'll show you a little bit of the architecture diagram to show you how I made it modular. And then we'll show you the application in Azure as well as a Power BI report that utilizes what the application produced. All right, so let's talk a little bit about scalability. I'm going to give you a consultant answer here. What does scalability mean? It depends on the application. Now, what I mean by that is every application is going to be able to scale differently depending on the use case of the application. For instance, a web application, if you're doing something for, like, say, the Super Bowl, you're going to need to scale to the amount of user clicks or orders or throughput that your application is going to receive through a web front end. If you're designing a database application, typically you're going to scale through maybe the amount of requests, the size of requests. So scaling depends on the application. One of the things when we talk about scalability that helps us scale an application, though, is breaking our work units into individual pieces. And this is so that our scaling functions that we do, in this case Azure Functions or other Azure services, can utilize individual pieces of work, and you can scale different parts of your application. And then when people talk about scalability, there's usually a scale up versus scale out. In general, up this means for a dedicated resource, you're giving it more processing power, more RAM, more I/O, where scaling out is you are creating more of a server resource to process your applications. In our case, we are going to be scaling mostly out with Azure Functions, but something like a database server, for instance, you could scale up to handle more I/O, but you can also scale out with Azure to do something like database sharding, so that with Elastic DB, you can spread the load across multiple databases. All right, so let's talk about some Azure function basics. So Azure functions are event-driven. And what that means is there are triggers that when that trigger occurs, it's going to call your function that you built and run that. And let me quickly flip over. One second. To some of the different triggers that are available in Azure. So you'll see here that when you create an Azure function, you have a lot of options of different things that can trigger your Azure function. There are common ones that a lot of people are going to use, like HTTP triggers, which basically gives you an endpoint that when your function receives a HTTP call, you can run the code. There's timers, there's queues, which is Azure Storage Queue, which I actually will be using in our app. And then the other one that we're going to be using a lot is Blob Trigger. So when a file lands in an Azure Blob Storage container, you can trigger the code that runs. There's a whole bunch of them here. I won't go over all of these, but you'll notice that there's a lot of different things that can trigger your functions, and they're adding more all the time. Back to my slides. All right, so this second bullet point here is on-demands, what Azure calls serverless. Now, as we all know, there's no such thing as actually serverless. What they mean by serverless is we don't have to manage the hardware behind it. It's going to automatically queue and spin up to meet our demand. So I, as a developer, don't have to worry about necessarily how do I spin up extra VMs or extra front-end web controllers or whatnot. Azure is going to handle that for me. And the way that this works is depending on the trigger in Azure for the Azure function, it's going to automatically scale up to 200 instances that can handle the rate of events coming in. Now, depending on the type of event, whether it's a storage queue or a blob trigger, it has its own logic on how it handles that. And generally what I've seen is, like, I think once every 10 minutes or so, you'll see it spin up a new kind of Azure function instance. But I've seen dozens and dozens and dozens of my function calls being evaluated at once. And one instance of Azure function can run many of your calls. So you could have one function of code being called 10 times from one Azure function instance, and then as that instance gets busier, it will start spinning up more to handle more requests. And finally, Azure Functions are developer facing. It obviously has the word function in the title, but just so you know, these are code dependent triggers and tasks that you're writing. So generally you're going to be writing C# code is my preferred language, but Azure Functions do handle other things besides C# code. Actually, when we go back to this screen here, you'll see that different triggers have different languages underneath them. So you'll see some say C#, F#, JavaScript. Those are probably the primary three that you're going to see, C# and JavaScript. Now, there is experimental language support. Some of these triggers can support other languages, mostly the web-enabled ones. So if I turn this on, you'll see a lot more languages pop up here. So we see things like Python, PowerShell. I think there's PHP for some of these. So again, mostly a lot of these web-based triggers will allow support of other languages, but it is experimental. It's not mainstream yet. All right. So let's talk about the application that I built with Azure Functions. So I wanted to do something fun, something that generates lots of data. One problem I've had with demoing proof of concept applications in Azure that we call big data is it's hard to get a good source of what we call big data. There's not really many publicly available data sets that are going to give you
Hey Josh, are you still there? I can't hear you, and I don't know if you we either lost audio or if you're on mute. All right, everyone. It looks like we're having some technical difficulties here. I'm going to try to see if we can get Josh back or figure out what's going on. So if you could just hold tight, we should be back to normal in a few minutes.
Hey, Eric, can you hear me now?
Yeah, I can hear you now. That was
I'm sorry,
weird.
well, no, my headset somehow got unplugged. I didn't
Oh,
even notice it.
okay. Well,
So,
if you
where did you
can,
lose me at?
I would say about 2 or 3 minutes ago.
Was it at the beginning of this slide though?
Yeah,
Okay, I'll start over on this slide. Just
awesome. Thank
it,
you.
yeah, if that happens again, just ping me. Sorry about that.
Will do.
All right, so yeah, let's talk about how we are using Azure Functions to create a video processing app. So when I wanted to create an app that generated lots of data, I kind of settled on something that I wanted to generate hundreds of thousands of text files, and it's hard to find a public data source that has that amount of information, right? You can get, maybe single files or maybe a couple dozen files, but for me, that's not a real big test of like big data capabilities. That's not a good test of how do we utilize data lake and use SQL and do some of those big data type tasks. So videos are just a series of images, and if you take a video and say 30 frames per second, basically means every second 30 images are being generated. So you can imagine with a long video, you can generate thousands and thousands and thousands of images. So what we're going to do is we're going to take those images and we're going to say, copy them off the video, save them to a file, and we're going to run some OCR technology to generate a text file of the text that occurred in that frame. And then we're going to dump that into an Azure Data Lake and do some analysis on that. And text on a video is just kind of one use case. It's an easy use case. There's a lot of good open source OCR libraries out there. Kind of at the end of this webinar, I'll show some kind of future things we could do with it, like object recognition and audio recognition. But for the purposes of this demo, OCR is kind of a nice, easy to use example. So we're going to feed our video application, actually a training video that we've done at Pragmatic Works, because training videos typically have lots of text on slides, they have demos, screenshots, so lots of juicy text information that we could grab and do some analysis on. All right, let's talk about the actual piece of the Azure stack that we're going to be using. When I was first developing this, I played around with lots of different pieces. I kind of settled on this as a first stage proof of concept. There are things like logic apps that I played around with to see the scaling on that. Azure Data Factory, this is back with the V1 days. V2 is much improved. And I would probably work that in here somehow. But our main pieces that we're going to be working with is Blob Storage. Blob Storage is great with binary files, right? So we're dealing with videos. Videos are large binary files. We're dealing with images. Blob Storage handles all that stuff really well. Of course, Azure Functions, that's kind of be our main processing unit here of how we move things between these different services. We are going to use the Azure Storage Queue, and I'll get into that a little bit with the design. While Blob Storage is great for, like, say, passing files and saving files, sometimes we need to store a little bit of information about what we want to do with that file, and a storage queue is a great place to kind of land, here's a location of a video, and here's some stuff I want you to do with it, and it buys us some more of that modularity, because then the Azure function can pick up on that and process the queue as fast as it can. We'll be using data lake storage, and this is for the text files, right? So while Azure Blob Storage is great at binaries, Azure Data Lake Store is great at text files, especially many, many text files. And like I said, one video that I can put in this thing can generate hundreds of thousands of text files if it's long enough. We'll be doing some Azure Data Lake Analytics, and this is just a little bit of USQL to clean up our data. It's I just did it kind of as an example. We're gonna remove words that aren't long enough and some things like that, so that our Power BI can show you some fancy reports on that. And we don't want, like, the word the, for instance, appearing a bunch of times. All right, so our kind of main technologies that we're using that are open source here to do a lot of the video processing, right? So while Azure Functions is doing a lot of our logic, I don't want to have to rewrite how OCR is done. I don't want to have to rewrite how you save an image from a file. So these are two great pieces of software. FFmpeg is basically a kind of open source video player, but it also does a lot of other things with videos. We're going to be using it to split the video into chunks. We're going to use it to save the images from the video. We can also use it to do some measuring of the video, like how long the video is. And then for our OCR framework, we're actually using Google Tesseract. Microsoft does have a service as an OCR, but at the time I'm not familiar enough with it. So Google Tesseract is another one that's out there, and it's an executable, right? So one of the things that functions can do is it could run executables that you upload to your Azure Function app. So both of these things are executables that will be actually pointing at files, and these scale as well. So it's pretty cool to see in action. All right, so let's talk about a little bit about the architecture. Let me pull up my Visio. All right, so this is kind of a high-level architecture of how I design this application so that it's modular, right? So again, when we're talking about scalability, we want things done in little chunks as possible, and also we want things to be able to pick up with Azure Functions in little pieces so that Azure Functions can scale as we need with lots of little chunks of work. By default, and here's an important note, if you're on the consumption plan for Azure Functions, your function by default has to complete within 5 minutes. So it's already pushing you to do small amounts of work in one function. Now we can increase that timeout to 10 minutes, and I'll show you how to do that because I actually did that on my application when I was testing, but that's the max right now. You can use an app service-based plan, which basically means you're hosting this on your own VMs, and your function can run longer, but then the scaling is a little bit different. So the consumption-based plan is kind of the default. I think it's the one that most people will use, and that's basically letting Azure scale all our resources out for us. All right, so the way this application is going to work is we're going to have a video file, and in my case, I just did MP4s because that's one of the most common video file formats out there, and it's going to land in a blob storage container. Now, how it gets there in a real-world scenario would just be dependent on your app. Maybe users are uploading it, maybe you have an application or Azure Data Factory moving the file to this blob storage. In my case, I just trigger it manually by uploading the file. Now, as soon as it hits that blob storage, it's going to queue an Azure function trigger. that trigger, this first function here, is going to split the video into smaller chunks. And the reason that I did this is so that we don't have that timeout issue that we're having. So when I originally did this with small video files, I wasn't doing this, right? And I was generally completing in 5 to 10 minutes. But as I pass it longer and longer videos, say a 30-minute video or an hour-long video, obviously doing a lot of image processing on that length of video takes a lot of time. So what I did is I made the work more modular. I actually split the video into 10-second chunks. So, a 3-minute long video, I split into a whole bunch of 10-second chunks so that we can do smaller units of work with Azure Functions. Now, because I did this, if I want to maintain like my timing in my videos and know when a word occurred at a certain time, we're going to have to do some math to get some information back out. Then those video chunks, so these 10-second chunks, land in another Blob Storage container, which triggers another Azure function. So every time a 10-second chunk gets in there, we're going to be triggering another Azure function. So this Azure function is actually going to look at that video chunk and look at the frame rate that we want to do, so say 30 frames per second, and identify all the points in the video that we want to take the images from. So this is kind of just setting up our storage queue that we're going to use to grab all the images from the video. And so we store that in an image cube. Again, this is a lot of information, right? So that storage queue needs to know the video name, the location, maybe the time of where that image occurred so that we can do some extraction. So this is sitting in an Azure storage queue. You could also use something like event grids or event hubs. I just use the storage cube because it's pretty easy and fit my use case pretty well. And then while that information is sitting in the queue,
Josh, can you hear me? All right. Looks like he lost his audio again.
oh, sorry.
Okay.
Yeah, I apologize.
Is
I
it
don't know
your
why that keeps
headset?
happening. The USB is really loose on it, so if I move my mouse, sometimes I think it's bumping the USB. I might need to get a new
Oh, okay.
headset.
All right. Just double checking.
So I'll go over the last. I don't know if you just lost me.
Yeah, we just lost you like 30 seconds ago.
Okay, so yeah. The next function is going to be picking up from the storage queue, and basically the storage queue now has for video chunk 1, I have 300 entries in the storage queue to grab images at 0.1 seconds, 0.2 seconds, 0.3 seconds, 0.4 seconds, and so on, and is actually going to extract that image and land it into a blob. And then our final Azure function is the actual OCR part of this. So this is where we're going to call the Google TestDirect plugin, and it's going to save that image OCR into a text file. So this grabs essentially a bag of words as a popular phrase of that image so that we can do some analytics on it. That's going to land in a data lake store. From there, we're going to do some USQL to do some cleanup. And finally, we can do some Power BI to do some analysis on this. So let's jump into our functions. So here you'll see we have our functions app. So this is Azure. It's an Azure function. I call it split video. And so split video is the function app, and underneath that is lots of individual functions. Now, these disabled ones that I have are just older versions when I was messing around with things, but you do have that ability to disable the function, which is nice if you don't want it to trigger. So our first function here is the monitor landing one. This is the one that's watching for videos. I'm actually going to go over the code in a second in Visual Studio. I don't want to go too far in the code. I'm not going to go line by line. I'm just going to talk about what the code file does and maybe any gotchas. But you can actually edit your code here and run it. You can also do it in Visual Studio. Now, if you do it in Visual Studio, some of the syntax is slightly different if you're uploading straight from Visual Studio. So when I show you what I'm doing in Visual Studio, it's just a copy of this code, just so you can see it a little bit easier. Now, when you're in an Azure function, you'll notice over here as well that we have a list of files, right? So this is your Azure Function app instance, and basically the files that you put in here are shared between, as the instances spawn up, these files get copied so that, your code can reference this information, right? Now your run.csx is your code file. That's where your function goes. Anything else in here, the function JSON is also default. It just kind of contains some configuration options. But anything else in here I've uploaded, or another function has created this folder and done some uploading. So these are actually folders for different videos that I've uploaded. And then you'll see in here that I have my ffmpeg.exe. So like I said, Azure Functions can call executables. And all you have to do is upload it here, and we're going to use the process C# class to call an executable. So this gives you a lot of power on a lot of different applications that you don't necessarily have to recreate the wheel if you have a functioning executable that could run via command line. All right, so let's go into a couple of the code functions here so you can kind of see how an Azure function works. So I'm going to bring over my Visual Studio window. And the very first thing I want to mention here is at the top here, right? We have this R reference, and this is so we can reference other assemblies that are either included in Azure or we've uploaded custom. So in these, if you ever see the word DLL at the end of this, that means it's a custom one. If it doesn't have the word DLL, it means it's one that's built into Azure Functions, just not included in the default namespace. Azure actually has a good list of these here. So on their developer site here, all of these are built in. You just have to reference with that R syntax. But you can also reference custom assemblies that you've uploaded. And I actually do that for the Azure Data Lake stuff. You'll notice that in this list here, there's nothing to do with Azure Data Lake. So we had to actually upload the DLLs for that ourselves and reference those. So our first function is what's monitoring that landing area. And you'll notice here that we have this blob stream, right? So this is our input to our function. This is Azure function. It's going to pass us information about that blob that we can use in our function and do stuff with. A lot of this other stuff is kind of default for how it does the logging. So you'll leave that in there when you create your own function. And just a quick note that when you create your function and you choose that trigger, it does create this template for you. So for instance, I'm going to create another blob trigger function. Scroll over. And notice here, when you create the function, you get to specify a path and a connection. So you can share the connections between your functions, and it just basically puts that information in the JSON behind the scenes for you so that you don't have to configure that yourself. So I will use, for instance, my one I built for this application. And notice it gives me that kind of template here that has the blob, maybe the name of the file that's put into the blob, and you can do stuff with that. So you don't have to worry about setting up that Azure Storage connection if you define it when you're creating the trigger. Now you can manually create it if you wanted to. You could put code and reference DLLs and create connections, but it's much easier to let Azure do that for you. All right. So this function, like I said, we're monitoring our landing zone, right? As I said, we're gonna be chunking the video into 10-second chunks. I just put this as an option here. I could have made a configuration, but for now, I just put it at 10 seconds. We're doing some stuff with the file names just to break out the file, from the extension. We're checking if it's an MP4 file. And then we're setting up the process to run FFmpeg, right? So this is kind of an important part if you want to run a process, right? So you can reference wherever that exe was, where I was showing you. It's D drive, home site, www root. You can hard code this here. I was using this pattern a lot, so I put an app name here that matches my function name. And then the important part here is this is reading the file from Blob Store that's being passed to our local instance so that our executable can do something with it, right? In our case, FFmpeg can't address Azure storage locations, right? So we are going to copy that video file locally to our Azure function and then do some work with it. So we're setting up a byte array, we're copying the blob down to our local temp directory, and then we are actually setting up the process. So this is setting up FFmpeg with the command line arguments. So, I won't get into the specifics of this, but this is just what's segmenting it out into 10-second chunks. And when we do this process start is basically when it's going to run the executable. And we wait for the exit. And then all we do is we actually are going to write the files out to another blob container. And in this case, you'll see that I am setting up the connection manually, right? So I am setting up this connection here to this Azure storage location, but I am using my predetermined connection. So this video process underscore storage is the connection I set up when I set up the function app. So I'm connecting to it, but this is a different folder. So I'm changing the attribute. And then I'm just going to upload using some Azure Blob Storage Cloud Blob class methods to actually upload the 10-second chunk of the video to this new location, which again will trigger another Azure function. So that other Azure function that actually gets triggered is the chunk function, right? So the first one, split it down into 10-second chunks, saved it out to that new directory. This one is going to take that 10-second video chunk and identify where in there that we need to grab our images from and put that into a queue so that another Azure function can do stuff with it. So again, this template is almost, it's similar, right? There's some
Hi everyone, I'm working on getting him back again. I'm really sorry
back
about
again.
these. Yes.
Gosh, sorry. That's if
You
you
need to
want,
put
I can
a
try to
tape
switch
on
to a
that
different
USB or
headset.
something.
Well, I could try to switch to a different headset too. Because I don't want to keep losing me.
Yeah.
We're already. Hold on, give me 1 second. Sorry about that. Actually, I'll try my other port too. I might lose my other mouse though. Hold on. All right, 1 second. All right, can you hear me now?
Yes, I can.
All right, so this is a different one and a different port. So we'll see how it goes. Sorry about that. All right, so I was talking about the system environment variables. So Azure Function lets you share environment variables across functions so that if you have a configuration setting that you want to share, in our case, the video frame rate, you have that option. So, how many images a second that I want to grab, I actually reference this in a couple different functions. So rather than having a variable that I have to configure in each individual function, I pass it as an environment variable. Let me show you where that is. So if you click on your function app itself, Give us a second to load. Here we go. Up here. There's an applications settings. And under here, you'll see here we have a bunch of environment variables. Now, some of these are built in and we don't really need to mess with, but I added one that has my video frame rate. So if you hit add a new setting, that you can basically add a new environment variable that you can reference in your code. And in my case, I'm setting it to 10. So basically every second I'm grabbing 10 images so that I can reference this environment variable across multiple functions. So in this case, we're actually using a different executable that comes with FFmpeg called ffprobe. All that does is allow us to get stuff like the duration of the video so that we can do some math. And it's a lot faster than playing through the video to figure out the duration. So that's all this is doing, but it's doing the same concept. We're just setting up a process, we're calling it. And because we need the duration of the movie to be able to know, where the end of where we're getting our images from. So here we're doing some math, and like I said, this is where we have to do a little bit of math because we're breaking the video into chunks. So imagine we had a 30-second video that we broke into 10-second chunks. I have a chunk 0, chunk 1, chunk 2. I need to know that in my chunk 1, it actually started 10 seconds after chunk 0. So all this is doing some math basically off the file name a little bit to know which chunk it is, to log the time in that video so that I can use that information later, because we don't want all our times to be off and reset every chunk. We want a contiguous bit of information that says at 30 seconds into the video is when this text occurred, not 1 second into that individual chunk. So we do that math here, and then we actually are just outputting to our storage queue. And notice this is pretty easy. I didn't have to connect to the queue or anything, because when I set this up, it actually asked me for a storage queue connection, and it's passing that information in for me as output queue item. So I, again, don't have to do anything fancy. Azure Functions handles passing that in or out, and I'm just literally adding a comma delimited bit of information to the queue. So this is going to take where that video is located, the name, the actual time, that's the math I was talking about doing, where in that chunk I'm going to seek though, and then the frame rate so that it knows the frame rate. Although once I made this environment variable, I probably don't need to pass this into the queue anymore. And then, so now we have all this information sitting in our queue. So, for one video chunk, it knows I need 300 images or 100 images in our case, because it's a 10 frame rate. So there's 100 messages for each chunk in there. We actually need to start saving those images off to a location to do some OCR. So everything at this point has still been in video format. We're just getting everything ready. So again, the format of this is similar, although it's a little bit different because this is dealing with a storage queue. So you'll notice that we are taking in some message parameters and we're doing a split. I did a storage queue is this kind of simple string message here. So I just put it as a comma delimited list, and I manually split it to get information back into my variables. So that's one way to do it. There's probably other ways. It's the way I figured was the quickest and easiest. And because this is a storage queue task and a trigger and not a blob storage trigger, we do have to connect to our blob storage accounts to get the video file information. So it's that same process again, though. I don't have to set up the connection again, but I do have to do this attributes thing to set up where I want to read from. So this is kind of dynamically telling the function where to read from. And again, we're going to use FFmpeg to save the images off the video. So we're going to set up the process information. And this is what downloads the file to our temp location again, because we need the file locally so that FFmpeg can work with it. We're going to set up the process. Notice here when we set this up here, this part here, if you know FFmpeg, is what kind of saves it out into an image. So we're saving out into PNG format. You can also do JPEG or TIFF. Like, it supports a bunch of formats. I like PNG. We decided to use. And I also found that with Google Tesseract, PNG works the best because it's kind of a lossless format. So for reading text, I do suggest PNG, but if you want to save on space, something like JPEG may work better. You may have worse results with OCR. And then, so this is going to save these images out to a temp location on our Azure Function instance. And then obviously we need to upload these images somewhere so that our OCR function can deal with it, right? So we are gonna make a new, upload it to a different container called images. So this is our storage account we're writing out to, but it's still the same storage account connection information, and we're just using a different container. And we're just gonna upload all these little images that are being saved out to the images container, and that has another function monitoring that, right, which will trigger each individual image as a function. So you can kind of see how this kind of is starting to scale out in like a blooming fashion, right? One video, it gets split into four chunks or multiple chunks. Each of those chunks put a whole bunch of messages into a storage queue. Each of those saves a bunch of images out to an image location. Each of those start getting another function. So as this is processing multiple videos or videos that are longer, it's not logarithmic, but it almost, you see an expanding pattern of how Azure Functions is scaling to meet this, and part of it's the application design. Obviously, for an individual function, Azure Function, will expand to process more messages or more files, but we also wanted to build it in a way that we can utilize more and more Azure Functions by building our application modular, so the individual units of work can trigger more functions, so you have things running in parallel. And then our final bit of code here is the OCR process itself, right? So now we have a bunch of images in the images folder. We want to do the OCR with Google Tesseract and save that text file out to a data lake store. Now, as I mentioned before, right now there's not a trigger that supports the connection to Azure Data Lake Store by default. So we have to manually do that. We actually had to upload the DLLs to connect to Azure Data Lake. So that's why you see the .dlls in these assembly references here. I had to upload those so that it could connect. And because this is Azure Data Lake Store, the connection method is kind of still the old school. We got to create an app with a credential. We got to have that credential and subscription ID, and that's how we're connecting to our Azure Data Lake Store. So let's go over the OCR piece of this first. We're checking to make sure, we're only dealing with our PNG extensions here that landed in the container that we're monitoring. We're going to set up the Tesseract exe process in this case. We're doing something similar. We're copying it from that storage location down to our function app location. Then we're going to run the process to OCR it. So this is for each image is going to create a text file. It uses the name of the file, by default for Tesseract, and it's going to create a text file. Now, the thing is that text file is not a good format for us to do data analysis for, right? So let me see if I can actually flip over to show you an example of that. So I'm actually going to bring up Azure Storage Explorer, and you'll see here that here's some examples of what the text files look like, right? So the default, let's see if I can find a good one. Yeah, so in this image frame here, so this is actually frame 100 in this module video, this is what it looks like. And what you can't see is there's also new line breaks in here and stuff. It just doesn't come across a notepad. But by itself, this is not good information. I mean, it could be in a general sense for like a machine learning algorithm, but for doing data analysis or SQL against, it's not great. So we're gonna have to do some manipulation of this file. Do we want to turn it into something that looks like this? So this is actually what we do in this function for that exact same file, and we just add some information in here, and this starts to look a lot more useful. So we add the file name with the frame that this occurred on, the order of the words in case that matters, the word itself, and then the time index of this frame in case you don't want to reference things by frame number. So that's what this function is doing. So this is, basically taking that information, we're taking anything commonly that would be like a new line character or something like that, and splitting it out into individual lines. And then for each of those, we are writing to a new text file, and we're also making sure we filter out only letters and certain symbols so that we don't get a bunch of junk in there that it couldn't recognize. And then the last piece of it is now we have that text file in a prettier format. We need to upload that to our Azure Data Lake store. This is kind of common if you've ever done any C# with Azure Data Lake store. Pattern's pretty similar. You have to set up your subscription. You have to have a web app and a secret and a key. I obviously obscured mine here, but you would put that information here so that we can connect to our Azure Data Lake store. Here's the path I want to put the file, and then finally we just do an upload file. So this is going to take all those text files and upload them to our Azure Data Lake storage. So at this point, we're ready to start doing text analysis. So what happens is we have all these files sitting in our Data Lake storage. So that is called video text, right? So this is my Data Lake storage account. And I'll just go to Data Explorer just to kind of give you an overview here. So this folder is where all those files land. And you'll see here that it's not going to be able to even display all of them. I have too many files. I generated so much information that's not going to display all the files. It has a limit of like 50,000. I have way more files than that. Showing me the first 10,000. But each frame of that video, and I actually have multiple videos in here, but each frame of every video gets put into this folder so that we can do some analysis on it. So all this is the OCR information. So what we're going to do is, one, for our purposes, we're going to evaluate this with Power BI, but while Power BI can connect to Azure Data Lake, and we actually do that, it likes a single file. It doesn't handle thousands and thousands of files really well, right? So we're actually going to merge all this information back into one file so that Power BI can handle it, and we'll do like a tiny bit of scrubbing just to show you some USQL. So in that case, we are using Data Lake Analytics, which is USQL. And I created a job. It creates one master CSV file, right? So I ran this last night. It takes a little bit of time to run. You'll see that it processed 2.9-ish million rows. And here's the script. Sometimes it doesn't highlight very well, yeah. So it's a really simple USQL script. So if you're not familiar with USQL, it's like SQL, but it's also like C#. So it's a little bit of a middle of the road between the two languages. So you just have to get used to it. I do have a copy of that here so that we can see it a little bit prettier. But one key thing that's it's cool to learn in USQL is here that when I'm reading and creating this extract here, I can pass it a star, right? So this is every file in this folder is going to create this extract. So it's going to do this for all that files as opposed to one, and combine it into one table for me, right? And then from that search video thing that I'm doing, all I'm doing is I'm filtering out if it's, they didn't find any words in that frame. And also I'm only looking for words that are lengths that are greater than 3. And this is again to filter out the A's, the thes, the ands, and sometimes it's garbage that appears in there. So again, very little manipulation. You could do a lot more here if you wanted to in this layer. And then we are saving that out to a CSV file called master. And so finally, to bring it all together, and I want to leave some time for questions, is we bring this into Power BI. So Power BI can connect to Data Lake. So this connection here, let's see here, is a Data Lake connection to connect to that CSV file, right? So what this is allowing us to do is do analytics on our video, essentially, right? So we have all this text that's sitting in this file. I did a kind of a word cloud, right? So in this training video that we have here, these are all the words that appeared. And this is one of our trainer, Devin Knight's videos on creating calculated tables and columns in DAX. So obviously you'll see some words appear a lot there, right? And we kind of filtered some top words used. Now you have to realize, right, we're looking at text occurring on videos over the whole video, right, frame by frame. So if something appears on the screen a lot, obviously the word count is going to be a lot, right? Because imagine you had your company logo at the bottom and it was OCRing that every frame. That's going to be probably your most commonly used word, right? And basically, we actually have the ability to search by words, right? So, if we look at one of these videos and I do something like, when did the word calendar first appear? I can basically look and, I have, obviously you see every frame that appears, but I can look at to see it first appeared at 2 minutes and 50 seconds in this video. And I actually have this open. So if I come here and look at 250, see the word calendar is on the screen, right? So that's when he first brought this up, and the word calendar is on there. Probably OCR, maybe both of these. It just really depends. OCR is not perfect, especially I didn't do any fancy training with it, so some of these words get jumbled up. So we are nearing the end of our time, so I want to leave a little bit of time for some quick questions. Sorry about the audio issues. I should have switched the headset the first time, but this one seems to be working much better. So I don't know if you have any questions, Erica.
All right, let me go ahead and open up the question panel here. Okay. All right, I have a question. In general, Azure Functions can run for some time, like 10 minutes only. How can you use it for longer duration runs?
Yeah, so like I said, like I had it in this case here, 10 minutes is the max that you can set right now under a consumption-based plan. So I had to split apart my units of work to fit that, right? I had to split the video into chunks and split those chunks into images and use storage queues. But that also bought me scalability. If you have like a one long-running process that you cannot split out, then the app service-based plan is going to be your best option. That can run as long as you want. Those processes can be longer, but it also may be the case that maybe Azure Functions isn't the best solve for that issue. You want to use something like Web Jobs or something, Azure Web Jobs, that can also be log running. So it depends on your use case.
Okay. Looks like we have more questions coming in. Kenneth asks, can you run and test your code within Visual Studio, or does your code always need to be uploaded into Azure Functions to test it?
No, you can run and test in Visual Studio locally. Like I said, the syntax is slightly different on how you declare some of the parameters and variables. There's a nice little document on the Azure website on how you do that. But you can do that. But you also have the ability to test files and stuff. So let's see if this comes up real quick. But in the Azure Function Online, you'll see there's this test panel here, and it allows you to basically pass it a sample trigger, whether it's a file or whatever, to process through, so you can test your triggers working with the right information without necessarily having to upload an entire video or something like that.
Okay. William asks, when do you want to store files in Blob versus ADLS?
So, my kind of rule of thumb, and it's really different, for every use case, but Blob is great for binary files, right? So when I say binary, I mean like images, videos, things that are large files, right? And handles storing that and accessing that really quickly. Azure Data Lake Storage, though, is great for text files and lots of files, right? Azure Data Lake Storage runs HDFS under the cover, so it can quickly scale to read from 500,000 text files. I think a lot faster than Azure Storage probably could.
All right. And is the demo code that you showed available for download?
Not yet. I probably release some pieces of it, especially like how to run the processes. It's not 100% complete yet. I didn't actually get to my slide of showing some future use cases for this, right? I want to do object recognition. I want to convert the audio to text files. Um, uh, but I will try to release some pieces of this, especially as like a template file so that people can quickly get started with how to write trigger functions and maybe like run a process.
Okay, and one last question here. Here's one. By default, we will have 2 or 3 parameters to the run function. How can we increase the parameters list? Where can you define them? Where can you define them so that I can use those values inside the function?
I didn't find necessarily a good way to do that, right? Because the template is being provided to you by the Azure function and what piece of information it's grabbing to you. But you'll notice what I did in one case is I wanted to pass information from one function to the other. I put it into a storage queue and used that to hold more information that my next function is going to process. Um, Basically, for what I understand, you're kind of at the whim of what's being provided to you. But like for instance, for a blob storage, you get the blob. You could then connect to that blob storage with the blob storage functions and then get more information. But I don't believe you can necessarily create a lot more parameters and control how those parameters get passed into the function.
Alrighty, well, I'm going to go ahead and wrap things up here. Thank you so much, Josh, for presenting today, and thank you everyone for joining our free webinar. As always, we do record all of our sessions. I have a couple questions coming in, people asking for the video, and if you'd like to revisit that, we will be sending you all a follow-up email that includes a link to that recording. I will also be posting the recording on our website at pragmaticworks.com. Just give me a few hours and I'll get that up on our website. So thank you again. Thanks again for your time, and we look forward to seeing you all next Tuesday for another free training session. Thanks so much, Josh.
Thanks, Erica.